What does it really mean for an AI to think? Today, we're diving deep into interview.net, high availability, and scalability. The remote hiring economy demands always on interview platforms. Candidate experience defines employer brand. Downtime erodes trust and talent pipelines. Performance optimized on .NET 8 with 40% higher throughput. Container native deployment across Azure Kubernetes service regions. Architecting for global distribution and elastic scale is a business imperative. But here's where it gets interesting: the reliability gap in existing platforms. Current interview systems rely on monolithic architectures with single points of failure. Peak loads cause timeouts and session corruption. A single server crash terminates all active interviews. Stateful designs force sticky sessions, blocking horizontal scale out. Global candidates face high latency from centralized deployments. Candidate frustration grows with every timeout. Legacy architectures cannot sustain 5 nines availability. So, what's the real problem? Let's talk about root cause: the monolith trap. Traditional .NET monoliths bind session state to server memory. Synchronous code execution blocks threads, reducing throughput. Vertical scaling reaches cost and physical limits. Hardware caps are hit quickly. Relational databases become right contention bottlenecks. The architecture resists elasticity, fault isolation, and global distribution. This raises a critical question: cloud-native .NET breakthrough. Interview.net rebuilt on .NET 8 minimal APIs and gRPC for low overhead communication. Microservices decompose the monolith into independently scalable units. Containers on Kubernetes with Kita and HPA enable demand-driven scaling. State externalized to Redis and event sourcing via Azure Service Bus. Resilience patterns, circuit breakers, retries embedded. YARP proxy and Dapr abstract routing, state, and pub sub for multi-cloud portability. Services own their data, eliminating monolithic database bottlenecks. Now, let's zoom in on multi-region active-active architecture. Global Traffic Manager routes candidates to the nearest healthy region. Azure API Management enforces rate limits and JWT authentication. Core Microservices Session Code Executor scoring run on AKS across availability zones. Azure Service Bus provides durable async messaging. Sessions preserve scoring order. Redis Cache holds ephemeral session state with geo-replication. Cosmos DB stores persistent results. API management enforces tenant rate limits. AKS node pools across 3 zones. Here's something most people overlook: core components decompation. Session orchestrator, stateless API with idempotent session creation. Context stored in Redis with TTL. Code execution engine, isolated container sandboxes per submission. Auto-scaled via Kita on QLink. Event Hub streams candidate actions to scoring and anti-cheat. SignalR service handles real-time code sync and video. Polyglot persistence, Redis hot state, Cosmos DB results. Blob artifacts, pre-warmed container pools reduce cold start. Code sandbox isolation via gvisor. Event schema registry enforces backward compatibility. Think about this for a second. Event-driven interview pipeline. Candidate code submission publishes event to service bus topic. Code executor consumes, runs in sandbox, emits result event. Scoring service processes asynchronously, persist outcome. Notification service sends real-time feedback via SignalR. Idempotent consumers with service bus sessions guarantee exactly ONS processing. Outbox pattern ensures reliable event publication. Dead letter queues capture failures for inspection. Pipeline processes 50,000 submissions per minute. And this is where things get complex: elastic scaling patterns. Keta scales executor pods from 0 based on queue depth, CPU, and custom Prometheus metrics, eliminating idle costs. HPA autoscales API pods on CPU and custom metrics, targeting 70% utilization. Redis cluster partitions scale with load. Cosmos DB autoscale absorbs write bursts. Predictive scaling via Azure ML pre-warms resources before demand spikes. Spot node pools for batch executors reduce costs. Capacity planning replaced by demand-driven elasticity. But here's where it gets interesting. Session lexical resilience. Idempotent session creation using UUID keys. State stored in Redis with TTL. Replicated across regions, disconnect. JWT token references encrypted session state and region hint. Reconnect resumes under 100 millimeters. No server affinity required. Heartbeats expire stale sessions gracefully. Kubernetes self-healing restarts pods without state loss. Geo-redundant Redis Enterprise with active-passive failover under 2 seconds. Active-active failover completes within seconds. So what's the real problem? Let's talk about fault tolerance by design. Circuit breakers via poly prevent cascading failures. Policies combine retry 3 attempts. Circuit breaker 50% threshold and timeout. Write with exponential backoff